Hi, this is Michel Birler. This video is part of a series on common mistakes in discrete choice modeling. In this episode, we will calculate aggregate elasticities. Suppose that we have estimated a choice model that predicts the probability that individual n in the population will choose alternative I. Suppose also that we have a sample of individuals from the population such that each individual n in the sample is associated with a weight wn. So the weights are designed to account for the sampling biases, and they are such that the sum of all weights in the sample is equal to capital N, which is the number of individuals in the population. Using this sample and the choice model, we can calculate the market shares of alternative I in the population. It's denoted by Wi, and it's equal to 1 divided by n, sum over n of Wn Pni. Let's now consider one variable from the model. Let's say variable number k. So for each individual n, xi and k is the value of this k's variable for alternative I. Now we would like to anticipate what will be the impact of an infinitesimal change of this variable to the choice and to the market shares. To do so, we will assume that the relative change of this variable is the same for every individual. So we assume that for individual n, the infinitesimal change of xi and k divided by xi and k would be the same as for individual p. So the same ratio of the infinitesimal change of xi pk divided by xi pk. And this is true so for any individual n or p in the sample, and this is equal to the infinitesimal change of the average value of the variable divided by the average value. So xik is the average value, is 1 divided by n times the sum of n, xi and k. Now we can calculate the elasticity of the model with respect to the variable xi and k. At the disaggregate level, it's denoted by E xi and k Pni, and it's defined as the partial derivative of the model with respect to the considered variable times the variable divided by the model. So this is called the disaggregate direct point elasticity of the choice model. Disaggregate because it refers to the disaggregate choice model. Direct because it measures the modification of the choice probability of alternative I as a function of a modification of a variable of the same alternative. And it's called point elasticity to refer to the fact that we are considering an infinitesimal change at a given point, at a given value of the variable. Now what we would like to calculate is this elasticity for the market shares at the market share level. So we denote the aggregate direct point elasticity as EWI_XIK, and it is tempting to calculate it as the market shares was calculated, meaning 1 divided by n of the sum over n of the weighted disaggregate elasticities. But this is wrong. This is not how to calculate it. So we cannot aggregate the elasticities in the same way that we have aggregated the choice to calculate the market shares. It does not work that way. So we will now show how to calculate the correct aggregate elasticity of the market share. Actually, what we need to do is to apply the same formula that we did at the disaggregate level, meaning that the aggregate elasticity is defined as the partial derivative of the market shares with respect to the considered variable times the variable divided by the market shares. Now, by using the definition of Wi, we can calculate this aggregate elasticity as 1 over n times the sum over n of Wn, the partial derivative of the choice model with respect to xik, times xik divided by Wi. This result has been obtained by calculating the partial derivative of Wi with respect to xik using the definition of Wi. Now we use the assumption that the relative infinitesimal change is the same for every individual in the population. We replace the infinitesimal difference of xik divided by xik by the same quantity for individual n. We multiply the numerator and the denominator both by Pn of I, so that we can actually reconstruct in this formula the formula of the disaggregate elasticity. And finally, we replace Wi by its definition, and we obtain the final formula for the aggregate elasticity. So it's indeed a weighted sum of the disaggregate elasticities, but what should be noticed is that the weight is not Wn. The weight is Wn times the choice probability. And so that these weights sum up to 1, this has to be normalized by the sum over m of Wm Pm over I. So when we aggregate the elasticities, we should not use the same weights as for the market shares. We should use as weight the weight for the market shares, Wn, times the choice probability. And these weights must be normalized.